Okay guys, perpendicular lines. This might be quite a big video, so you might have to come back to it a few times. This is the crunch section where it really starts to change, and it's a key area that's going to leverage a lot of questions you get on straight line and higher. So the expectation that at this point here you're moving into real more developed stuff, so just try and slowly follow this. Right, okay, you've obviously got two lines, right? Now what do we mean with perpendicular? And I'm sorry guys, I haven't got a ruler. I haven't got a ruler. Essentially perpendicular is there at 90 degrees. So if you've got M1 and then you've got M2, two gradients, right? M1, M2. If you times both of those gradients and you get it to equal -1, it's perpendicular at a 90 degrees to each other. Okay. Right, so let's look at it. So the kind of question you get is prove it's perpendicular, or that kind of stuff. So are these lines perpendicular? Okay, so that's what we've got here. So M1 equals a half, M2 equals -2. Now, there's a wee trick to do it, and I'll try to explain. If you can get one gradient and you can turn it upside down and then change it from a positive to a negative, so if you think about it, if you turn it upside down, that would become 2/1, which is 2. It's positive, so when you change it across to the other side, it would be -2. So that is perpendicular. Okay. Plus, also, if you times them, you get -1. But the wee shortcut is if you turn it upside down and you change the sign, and it works, they're perpendicular. Look at this one here. 2/7 and 7/2. So if you times them each other, you'll get 14/14, which is 1, but you don't get -1. But the trick is, look, you can flip them upside down, but look, there's not a change in sign, so that's not perpendicular. There you go, equals 1, lines are not perpendicular. Okay. So, look at this one here. M1 equals 5/2, M2 equals 2/5. Have a think about it. Is that perpendicular or not perpendicular? Okay, and you'll see that that one is perpendicular. Okay, next question. Consider the lines y equals 3/4x, 3x minus 4y equals 4, 4x plus 3y equals 6, which are parallel, which are perpendicular. So, if they're parallel, they have got the same gradient. So, and if they're perpendicular, you get this M1 times M2 equals -1. So the first thing you ever get when you get these kind of things, look, they're all mixed up. You want to change them all into this form. You must rearrange them into y equals mx plus c, so you can evaluate, and it's got to be y equals. So let's see what we've done here. So I'll just put them all up so you can see them. Oh, there's a lot there. Okay, let's go through them all. So the first one, y equals 3/4x, so the gradient that is 3/4. The 3x minus 4y equals 4. They've just rearranged it. What should they rearrange it? You've got to get this right. And they've called this M2 and they've called it 3/4. The other one, 4x plus 3y equals 6, up here. They've rearranged it into y equals mx plus c. We're not interested in the c value, it's the gradient. And they've got -4/3. So you can see we've got a 3/4, a 3/4 and a -4/3. So it looks as though M1 and M2 are parallel because they've both got the same gradient, and we're looking at M1 and M3, M1 and M3 and M2 and M3 equal -1 because look, they're flipped. Turn them upside down, different sign, and that one's the same to that. So you've got that one and that one are both perpendicular to this guy here. There you go. Okay. This question here is typical of what you'd get in an exam, right? So there isn't a diagram, so we spoke about before, start getting a diagram in there. So use a gradient to show that the points 3, 4, 8, 2, minus 1, 6 make a right angle triangle. So essentially what you're going to do, you're going to right angle triangle. Okay? So when you do it in your grid, but essentially you've got M1, M2, and you've got right angles, they should be perpendicular. Okay? So you need to do a wee rough sketch to get visualise where they're looking in a XY coordinate grid. So what have they done? But I don't think they've done that. I think all they've done is worked out the gradient between P and Q, Q and R, and P and R, and see if they've got, let's see what they've done. Yeah, that's all they've done. They've worked out the gradient between the 3 points, and to see if they could use an M1 times M2, and you can see it's that one and that one. So M PQ, right, times by M PR, well that equals minus 1, minus 2 over 5 times by 2, 5 over 2 would equal minus 1, so there you go. So they're perpendicular, so it's right angled at P, because the common point's P. Okay. 2 questions here just at the very end of this video, so have a read of it and then give it a wee pause and then give it a go. Right, 2 questions, one's relatively straightforward, one at the end's quite difficult. So find the gradient of a line perpendicular to the line of the equation 2x plus 3y equals 12. So have a think about it. Okay, so what that means is all you're doing is finding the gradient of the perpendicular. Okay, you're not finding the equation of that line, not yet. All you're doing is getting the gradient. Okay, so what you're going to do, you're going to rearrange 2x plus 3y equals 12 into y equals mx plus c, and you've got minus 2 over 3x plus c. So there's a wee note telling you what you've got to do. You've got to rearrange it, y equals mx plus c. It's all there for you, right? And what you do is you've got minus 2 over 3. So minus 2 over 3, that's a kind of long convoluted way. It's always good to make that comment when you're doing perpendicular equations, gradients, sorry, just writing that out. Okay. So look, therefore m tan upside t equals 3 over 2. So look, all we've done is turned upside down and then changed the sign, and there you go, 3 over 2. Next example would catch a lot of these out. Okay, so let me gear up. Okay. So find the equation of the line passing through the point 3, 5, which is perpendicular to the line of the equation y equals 4. Now hang on a second, what does that mean? Y equals, oh sorry, y equals, put my glasses on, y equals minus 4. Well, there's minus 4 there. I'm doing a really rough sketch, guys, of this, right? There's minus 4, so y equals minus 4 would be that. So perpendicular to the line, so that would be hard to, so there's my origin. Really rough, okay, but you should know there's minus 4. So that line there, that's y equals minus 4. So, and it's perpendicular to the point 3, 5. So if it comes down like that, there's my 90 degrees. So there's my x-axis. So that would mean x must equal 3. It's got to go through here. There's 3, 5. So it's 3 along and 5 up. So it's at 90 degrees. And that's me visually showing you that. Look, let's see how to do here. And I think it's harder. So have a look at that. So have a read at that. That's how to do it. That's me visually showing you how to do it, which I think is better. Okay. I want you to now have a go at exercise 3.